Today we have something different, and welcome back to my shop. This isn't my shop, this is, well, kind of, this is workshop. And today I have a RPT15. This is a RPU transmitter, remote pickup transmitter. There's the insides of it. This thing was new in the 90s, mid-90s, or early 90s actually, and it's seen some serious service. I've been through it a little bit and got it working, more or less. The problem with it was it wouldn't transmit but a tiny little bit, and and even that wasn't right. So I checked the voltages, thou shalt check voltages, and they were low. I'm supposed to have 13.8 volts right there, and I didn't. I had 10 point something. So I replaced this regulator over here. This is a LM338 voltage regulator, and that did not help. I checked all the diodes, capacitor, other things, and that didn't help. So I unplugged it, took it apart, unplugged this cable up here and this cable here, these two connectors, and all of a sudden my power came back. Unfortunately, that wasn't all of it. It worked, but not correctly. This thing is 450 megahertz, and what I got out of it, I'll show you here. As soon as I plug it in. Interesting. Alright, so what I got out of it was about 2 watts. Now I got 15 watts, you can see right there. It's closer to 16. But what the problem with it is, I'll show you this too, as soon as I get my little cheap excuse for a spectrum analyzer going. It drifted badly when I touched it, and I'll show you that here in a minute. Just put a little pickup coil in there so I can pick up the frequency. So this is supposed to be 455.05, and it's not. If you look up here, it's about 043, which isn't good. What we've got here, if you can see it, there's my carrier, and I'm going to expand this out. Now, if you notice up here, you've got, if you can see that, you've got some glare here. Let's do it this way. Right there at that red line is 455.00 or 050, and I have calibrated this little SDR software, SDR to exactly on frequency. And now watch what happens here when all I do is tap the top of this. Something is ringing in there, and it is not dead on frequency. What happens is when I get the thing all lined up, it'll drift on me badly. So we got to find out what's wrong with it. Wish I could get a position here where it would read. Okay, so now my frequency counter says 455.05, but that's not exactly accurate. It is saying it is 1 kilohertz off. Okay, well, so is the frequency counter. Okay, but 1 kilohertz is a lot when you're dealing with these radios. Now my problem here is, and I'll show you. Let's try it. We're on the first frequency here. Got my little flag, and I know which way my flag is pointed, right towards that way. Let's tune it up and get it right on frequency. And walk it in. There it is, right dead on the red line at 455.050. Frequency counter 455.050. Let's take that down a little bit and see what it says. Alright, that's fairly close. So, now, watch this. Well, now it won't do it. Make a liar out of me. Ah, see it? See it shift? There. It's off again. It's walked off to the side. Fair ways. So, what is that all about? Well, we're going to find out. Turn it off. Take these little screws out of here. Now, these transmitters are made to be turned on and left on for hours at a time. These aren't light duty. They're designed specifically for electronic news gathering or something like it, and they have heaters on the crystals. Here, I'll show you. Those are the crystals right there. Well, this camera's not real good at this. No. Let's back off a little bit. Well, anyway, there's the crystals, and they're wrapped around. There's a piece of rubber band wrapped around them, and the rubber band holds them against a little resistive heater element here, and that keeps them warm. Now, we have a couple of things that might be wrong. First thing we're going to check is see if this connector is good. Exercise that a little bit. Alright. Turn it on. There's my power. And watch it walk into frequency. It's dead up, 455.050. Not so much as the frequency counter would tell you that. Yeah. Right there. Try to get the glare out if I can. Now, let's tap on it with something, see what happens. Well, it's walking right back in again. Tell you what, we're going to let this sit for a while and get warm, and then come back to it. We'll see what happens. Back in a few. Well, okay, it's been about 15 minutes now, and now it does what I said it did. Let's expand this out and I'll show you. There's my picture, and when I just tap on it, or push on it, aha, see it? That ain't right. Ain't supposed to do that. So we got to find out what's wrong. What we have, there's the little board right there, and you can tell it's been soldered to. Well, interesting. We'll unplug her here and do some soldering of our own. Turn on the implements of destruction here. Take a look at it and see if I can visually spot something. This thing's been around for a while, and it's seen a lot of service. So the chances of it having that squeaking is my chair. It's what was left over. Let's see, as usual. Let's take a look and see what we got down here. Well, tell you what, there's a lot of kind of iffy solder joints. So let's attack those first. Tell you what, we're just going to solder it. Anything that even looks remotely, not even remotely, just go through here and methodically solder everything on this board. Start from the top, work my way across and down. And then we'll start. There's one that's got a little hole in the top. One thing about soldering some of this old stuff, or little transistor has been replaced, is that, there's one. The base had broken loose of the solder joint, and it had a little ring around it. We'll see. A lot of this old stuff, when you solder it, there's corrosion around the pins, and when you actually go to solder it, you'll notice that it'll look like the pin's sticking up through a little hole with solder surrounding it. What happens then is that little base where the solder is connected to the board breaks loose, and there's nothing connected. This is especially true on single-sided PC boards without flow-throughs. Well, that did not look good at all right there. Okay. Make sure I've got everything here. And that one didn't even look like it was ever attached. Alright, well, one more back here on the connector. Alright. Well, that looks like all of them. Let's plug it back in. Oof. See what it does. It does nothing. Okay. You still got a bad connect? Yes. Bad connectors. Right there, too. Okay, it's walking in on frequency. But it is nowhere near stable. Let's see what happens. Yeah, walked right off. So I wonder if it actually could be. I'm just poking on the crystals now. On the crystal that's... I think it's mighty warm. That, Well, interesting. We do have, however, a bad connector over here, and this could actually be part of it. Take a look. I'll show you. That connector right there Doesn't look good. And that's the power connector. Now, wow, it's cooked on there. And that's on the B+ line. And it's hot. Wow, okay. Now let's get this out of here and take a look at it. I noticed when I plugged it in that there was a spark. And that pin is not in the, ooh, yeah. Scrape, scrape, scrape. That pin, see if we can get a picture of this. It's that second pin from the left. And it's got corrosion on the back side of it. Alright. And it's got gunk all over it. The actual thing that connects to it has a burnt spot on it. So that tells me not making the best contact in the world. Right there, it's burnt. I have had to, from time to time, just take these things out and solder them in to the board rather than have them plug in like this. It's sort of a nuisance because if you have to go to fix the board, you it's permanently soldered in. Alright, here's the other one. And it looks okay. The pin has more of that corrosion on it. Okay, well, let's see. Let's put this back together again here. Come on, cooperate with me. There. Okay. So, let's get some cotton swabs and some deoxit. See if we can clean these off a little bit, and then I'll plug it in again and see if the this is the best stuff in the world right here. Yeah. So these two pins that are grungy on here are the power carrying. One of them is the 22 volts going over to the regulator, and the other one is the 13 volts coming back. So get that all cleaned off. Alright, now let's put it back on. Well, it went on a lot easier than it came off. Let's find out let's see what happens when we plug this thing in. I probably, let's see. Alright, here we go. Well, I didn't see any sparks that time. And it's transmitting. And it is way off frequency. Most certainly is. 2 kilohertz. Let's adjust it a little bit, walk it back in. So I'm thinking it might actually be a voltage difference. But then again, maybe not. No. So, I am beginning to believe, let's see if the bias adjustment pot is just flaky. Nope. Okay, it went off. Full kilohertz, and it's not coming back on. See you. Seems to get worse over time. Alright, let's try the other frequency. That's way off. Frequency, that is. It's dead on now. Now, does it do the same thing? Oh, even worse. Yeah. Interesting. Frequency counter isn't really showing anything off. The only way I'm seeing it is through my SDR. And I can watch the frequency shift on me. And I push on the board. Okay, more thinking to do. Oh wait. No, that's... I'm not turning these. These you don't want to turn. I'm just touching them. Wow. No, I'll have to think about this. Okay, we're going to try something here. Turn it off. Turn this off. Makes too much noise. Pull the rubber band off of the special rubber band off of the crystals, and we're going to there's goo on them. Alright, so I sprayed a little cleaner in there, and I'm exercising the crystals in there. Kind of really just jumping at straws here, because I don't know, it just does not want to. Here it comes, walking in. When you first turn it off, it starts way off to the side and then slowly walks into frequency. Did not walk all the way in though. But now it's walking away. Okay, so if I hold these crystals right up against this heater, I mean smashing against that heater, that thing is rock solid. As soon as I let it go away from the heater, even just a little bit, off it goes. So let's try. No. If I keep it on the heater, I mean mashed on that heater, it does not change frequency. Okay. So, this little band here. Alright, what we're going to do is we are going to get some stuff. If I can find it. It's heat sink compound. I just use the stuff that came with all of the different computers I've fixed over the years. Just make sure you don't get the multi-purpose lubricant and not the heat sink. There we go. So what we're going to do is we're going to pull this thing out of here. Give it a good we would give it a good dose if I get any more out. Give it a good dose of heat sink compound. Not down around the pins, please. At least this is going to be the first test, because this stuff that's on here is pretty much all dried out. And we'll see if just heat sink compound, more of it, more is better. In this case, put its little rubber band back on, which is fairly tight. I mean, it's not tight, but it's fairly tight. Alright. Now, let's turn it on. Let her settle in. Let the heater come up to temperature. And tune it back in to frequency. Okay, there's dead on 454.5. Okay. Let's go to the other guy. He's way off now. Alright. So there's that one. Now, let's give it a tap and see what it does. Nope. Okay, so it'll go off for a second, but it only goes off about 50-60 hertz. Maybe not even that far. That's pretty good. Well, now it's not hardly moving at all. Let's give it a push on the board. Comes right back on frequency. Huh. No, it didn't. If I push on this side of the board, it is rock stable. I mean, rock stable. If I push on this side of the board, I can get it to go off a few hertz. Not by much, mind you. But you can tell when I'm looking at this thing, it is just. Let's see if I can get a movie. My camera doesn't. It says the batteries are dead, which is interesting since they're brand new batteries. Alright, so now watch what happens when I just push on this side of the board here. Right there. Now I'm pushing. It's not moving worth a hoot. Now if I push on this side of the board, see it jump? I let up and it jumps back again. But when I push on this side of the board, just the tiniest couple of hertz swing. Because if you look at it, you can't really see it from there, but we're looking at one whole division left and right is 1 kilohertz, so it's not going very far. Gonna let it warm up for a while. I'll be back in a minute. Okay, it's been about 20 minutes. And it's even worse. Give you a shot here. That's just me touching the crystal. Now I'm not touching it at all. Touch it. Yeah. No, that's not. We look at this. I am not touching it at all. I'm going to try mashing the crystal up against the heater. Look at that. Wow, okay, it just rock solid as long as that crystal is mashed up against the heater good and hard. As soon as I let off, so I wonder, this little rubber band thingy is not real tight. I can't leave it on here because they get too hot, but I'm going to try something. I'm going to take a little short wire tie. And tie it on here real tight. Hate this goop. Okay. I have a feeling that it would not take very long for this thing to melt, this wire tie. I mean, it gets downright hot. But let's find out, because that is definitely mashed up against there good and hard now. Let's see what happens. Alright, there it is. It's off frequency just a tiny bit. Walk it back on. So, I think what this is trying to tell me is let's heat it up a little bit and see what happens. This should be interesting. Alright, so I'm going to add heat. Trouble is, I added heat to the whole blinking circuit. And it went up. Let's see what it does when it comes back down. See if it locks into frequency. Yes, it did. Here it comes again. I add a little more heat to see what happened. And it went low in frequency. Now remember, one division on that thing is 1,000 cycles out of 455 million 50,000. But a kilocycle is too much. Okay, well, I think I've discovered what it is. The heatsink compound was gone, and the little rubber band, this little guy right here, that holds it in, is worn out. Now I got to come up with some idea. That's definitely what the problem is, other than back here, because I'll show you. If I move this guy around, see, the power goes down. Well, it did for a minute. It will, trust me. There it goes. Wiggle. Wiggle, wiggle, wiggle. That's just the power supply. So I think I'm going to have to solder that right into the board, because those plugs are not doing well. Either that or clean them off a little. Oh, let's try that right now. Spray a little. But it gets darn hot. Yow. Yeah, I think I'm going to have to solder that right into the board, because that's not going to get it. Okay, well, that's neither here nor there though. But we did fix this problem. Well, we found out how to fix this problem. I need something to strap on there that's not going to melt. Well, that'll take care of it. Thanks for watching, and don't forget, if you like these videos, press the little like button down there, and subscribe if you want to see when I come up with more of them. Thanks for watching.